Hello everyone, this is my third lecture and today we shall discuss about the Coulomb force and its formula. In the Coulomb force, what is Coulomb force? A force acts between 2 point charges separated by finite distance is called Coulomb force. Again I am repeating, a force acts between 2 point charges separated by finite distance is called Coulomb force. Coulomb force only acts between 2 point charges. The charges should be pointed, number one. Number two, both bodies must be charged and the separation between the charges must be finite. These are the limitations of Coulomb force. The first is, it is the point charge. Number two, both the bodies should be charged. And the third one is the distance or separation between the charges will be finite distance. Coulomb's law of electrostatic is what? In this, we study about the dependence of Coulomb force on the different magnitude of charges and separation of charges. The first Coulomb's law of electrostatics is what? Coulomb force is directly proportional to the product of magnitude of charges. Means Coulomb force is directly proportional to the product of charges Q1, Q2. FC is directly proportional to Q1 and Q2, the product of point charges. And the second is FC is directly proportional to Q1 upon R square, means inversely proportional to square of separation of the two charges. On combining, if we combine this, on combining first and second, FC is directly proportional to Q1, Q2 upon R square. And on removing the proportionality sign, a proportionality constant is introduced, that is K. So K Q1, Q2 upon R square. And the value of K is equal to 1 upon 4 pi epsilon. It is pronounced just like this, EPSILON, epsilon. And for vacuum, we can express it F0 and it is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. For vacuum, K0 is equal to 1 upon 4 pi epsilon naught and its value is 9 into 10 raised to the power 9 Newton into meter square upon Coulomb square. And epsilon means epsilon naught permittivity of vacuum. Permittivity of vacuum. This is the dependence of Coulomb force on medium. And for vacuum, it has value epsilon naught is equal to 8.85 into 10 raised to the power minus 12 Coulomb square upon Newton into meter square. This is the value of permittivity. For vacuum is 8.85 into 10 raised to the power minus 12 Coulomb square upon Newton into meter square. And permittivity is nothing, it is the dependence of Coulomb force on medium. So epsilon is the permittivity of medium. Permittivity of medium, and we cannot determine the permittivity of a medium directly. It is defined as the relative permittivity, and relative permittivity is what? Epsilon r is equal to epsilon permittivity of medium upon epsilon naught permittivity of vacuum. So relative permittivity is the ratio of permittivity of medium to the permittivity of vacuum. And the second thing is, it can also be expressed just as the epsilon r is equal to F0 upon Fn. Relative permittivity of medium can also be defined as the ratio of Coulomb force in vacuum to the Coulomb force in medium. So these are the, and this is a unitless and dimensionless quantity. Unitless and dimensionless quantity. Dimensionless quantity. Because it is a pure ratio number, so relative permittivity is the permittivity of medium to the permittivity of vacuum, and also the Coulomb force in vacuum to the Coulomb force in medium for the same charges and same separation of charges. And this is the unitless and dimensionless quantity. And the Coulomb force, the final Coulomb force, is a vector quantity. We know that, and it is it is attractive for the unlike charges and repulsive for the like charges. Positive charges repel one another. Negative charges repel one another, and positive and negative charges attract one another. Now we shall study about the superposition of Coulomb force, and in this, when a charged particle, we can say Q0, is under the influence of a number of charged particles, we can say Q1, Q2, Q3 dash 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 Qn, and they have a finite distances R1, R2 dash 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 Rn. Then if this charged particle is under the influence of these all charged particles, then the individual charges exerts Coulomb force on the Q0, and the net or total Coulomb force on Q0 will be equal to the sum of Coulomb force, or sorry, vector sum of Coulomb forces exerted by the different charges. This is the vector sum of Coulomb forces exerted by different charges. This is called superposition of Coulomb force. So if the force exerted by Q1, force exerted by Q1 on Q0, F01 is equal to K Q1 Q0 upon R1 square R1 cap, and the force exerted by Q2 on Q0 F02 is equal to K Q2 Q0 upon R2 square R2 cap, and finally force exerted by Qn on Rn will be F0n is equal to K Qn Q0 upon Rn square Rn. So this is the force exerted by the charge Q1 on Q0. This is the force exerted by charge Q2 on Q0, and finally this is the force exerted by charge Qn on Q0 charges. So these are the different forces exerted by individual charges, and the total charge on Q0, total charge on Q0 is equal to the vector sum F is equal to F01 plus F02 plus dash 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 F0n, and F is equal to F01 means K Q0 Q1 upon R1 square R1 cap plus K Q0 Q2 upon R2 square R2 cap and so on F Q0 Qn upon Rn square Rn cap. F is equal to, it can be written as in the form of summation I is equal to 1 to n K Q0 Qi upon Ri square Ri. This is the principle of superposition of Coulomb force, and this is the vector sum. Means in the numericals there is a certain charge particle is under the influence of different number. It may be a triangle, or it may be a rectangle, or it may be a square. Then we have to calculate by determining the vector sum of all these charge particles on the given charge particle, and this will be the principle of superposition of Coulomb force, and this is nothing but the vector sum of Coulomb forces exerted by the different charges. This is all about the superposition of Coulomb force.